Baker Engineers has designed more than 1,000 bridges of virtually every description, from single-span deck girders to the world's longest steel arch. Soaring 876 feet over a scenic and remote river gorge near Charleston, the 3,000-foot-long New River Gorge Bridge, with its 1,700-foot arch, is the longest single-span arch bridge in the world. Designed by Baker Engineers for the West Virginia Department of Highways, this enormous structure was a monumental challenge in engineering design and construction. And no one knows that better than Frank Kempf.
When I first saw this site and walked up and down this gorge, my palms were sweating. I couldn't believe how we were going to get a bridge across this gorge. It was awesome, to say the least.
But awesome or not, the project proceeded. First with the exact location of the point from which the mighty bridge would leap. Then with the exploration of all feasible design approaches. What finally emerged as most efficient, economical, and aesthetically pleasing was a simple, clean, and symmetrical deck truss arch bridge, featuring a tremendous 1,700-foot arch span. Then came the challenge of construction.
When you construct an arch bridge, an arch can't support itself until the two sides of the arch meet in the center of the arch, or what we call the crown of the arch.
Supporting the arch during construction was a unique cableway system. Anchored to 330-foot towers on either side of the bridge centerline, the 3-inch diameter cables spanned 3,500 feet. Parallel construction began on both sides of the gorge, working toward the middle. Then, in the spring of 1976, both sides met. And from countless mathematical calculations, the great arch materialized.
I remember that day very well. I might add that it was probably one of the greatest days of my life when I was able to be at the dedication of the bridge.
The bridge was dedicated on October the 22nd, 1977, and officially opened with 4 lanes of traffic, operational all day, every day, except, of course, on annual Bridge Day, when 2 lanes are closed to traffic and open to parachuters from around the world. New River Gorge Bridge, a major milestone in bridge design and construction, a true collaboration of human ingenuity and advanced technology. Using advanced technologies in the solution of complex engineering problems and advancing those technologies even further has been a tradition at Baker Engineers since its earliest days. The Baker collaboration with advanced computer technology began in 1957 with installation of an IBM 650 and the creation of the first data processing center ever established by a consulting engineer. Ed Richardson was there.
We started in on highway design and structural design and some application to surveying. We did some rather basic things. The IBM 650 computer, of course, was a very limited machine. It had 1,000 addressable positions that you could use to program, and you had to write everything yourself. Actually, you can probably get about as much power out of a little handheld Hewlett-Packard today as we got out of that machine, although we did make it work for the company.
Baker's consistent capital investment in state-of-the-art equipment has resulted not only in fully integrated data processing facilities, but also in leading-edge photogrammetric mapping services, in a fully staffed water control laboratory, and in a complete soil testing lab. Baker's high-technology approach to engineering has been applied to all of its projects, in civil engineering and transportation, in operation and maintenance services, in architectural design and facilities planning, in environmental management, and in special projects like sports stadiums.
Fake to Collins. Bill sets, pumps, throws deep down the middle, intended for McDuffie. He's got it for a touchdown.
In 1958, Baker Engineers had solved an expansion problem at Penn State's Beaver Stadium by dismantling the existing structure and moving it a mile and a half away to be merged with a new 18,000-seat addition. And in 1977, when another major expansion was called for, Baker solved the problem by lifting the stands with hydraulic jacks, 12.5 feet, a section at a time, to allow for placement of new rows of seats immediately adjacent to the playing field. In between those Penn State expansions, Baker dealt with another major challenge: structural design and site development for Three River Stadium in Pittsburgh. Built at a cost of $35 million, Three Rivers opened for business on July 16, 1970, after 10 years of planning, design, and construction. Chief structural design engineer was Errol Lim.
The reason for going to a game and not sitting back at home on watching the TV so that you can feel that you are part of the action of the sports. You want to be able to hear the crack of the ball against the baseball bat and the clashing of the padding of the football players.
Short drop, fires over the wall, is caught by Hodge. 15, 10, 5, Merrill Hodge.
In designing a multi-purpose stadium, it takes a lot of planning so that you can bring the crowd into the stadium as quickly as possible to their seats. Also, while they're in the seats, they would have an unobstructed view of the sports that they are viewing.
No easy matter with a multi-purpose stadium, but Baker addressed the needs of both baseball and football fans with 2 banks of movable seats at field level. For baseball, these 8,000 seats are nestled around the home plate corner. Overnight, they can be converted for football, with 2 4,000-seat sections facing each other across midfield.